Hello, today I would like to talk about forces. First of all, what does a force do? Like, kind of what it is, all that type of stuff. So, a force is a push or pull on an object. Forces can also form acceleration and change state of motion. If some of these are confusing for you, like motion and acceleration, you will understand everything while watching the video. So here we have two box situations, let's say. The force over here is pushing the box to the right. So if you see a force that ends over here, ends to like the start, end, like towards the box, I guess. I don't know how to explain it. You can basically that's pushing it. And if you see force like this that starts from the box, that means it is pulling it. I think to remember is that forces can be on an angle. Like they can go from here, they can go like they're able to have an angle, and most questions will have an angle. Like over here it will be like 40 degrees or something. So just know that. So now let's talk about other important ones, gravity force. So let's say a ball is falling from the sky. The gravity force, like just put a G here if you want, is pulling it down. So it's dropping down, and there's like some air resistance, blah blah blah. But that doesn't matter right now. The main point is that the gravity force pulls down. Now the normal force. The normal force is kind of a complicated one, but not at the same time, basically. So you have the gravity force, right? And let's say right now we're on a table. So here's a table and the box. The gravity is working. So let's say the gravity force 10 newtons. There is this normal force that acts to the opposite of where the object and whatsoever is, and it has the same power as the gravity force. How it works is that, you know, like the world is created from atoms, right? So the table is also created from atoms. Yes, it's like they're extreme, like it's still solid. However, atoms are atoms. Let's say you're like put in a box, right? The atoms kind of bend, and because they want to be back where they are, they are pushing it back. So like it's hard to explain. But the point is that's just think of it as like atoms like bending and then pushing back open. That's just how it is. Even if it will be like, you know, on an angle, like let's say the angle is very small, it's like barely standing there. Let's say it's like 10 degrees. The normal force will like still come from the box, but also from the table, whatever it is. Like it goes like parallel to where it is. So yeah. So we have the gravity force. We have the pull force. Like we have the normal force, and we also have something called friction force. Basically, let's say like you have a box that you're like, you know, dragging, right? You're using a lot of power to drag it. Like let's say it's like 50 kilogram, right? And you're doing it on the hard concrete. Because it's not flat, there's lots of like stuff on it. You kind of have to use more of your strength because it's like bumpy, and like let's say like the bits, like the mountains, you have to like pick it up, and it's all like that. So basically what friction is, it kind of like it makes you use more power. Like it takes away the power from the power that you're using. Like you're using power to pull it, but you're also using the power to like actually make it move from the ground, if that makes sense. So if they're like most do have friction force, so friction force is the opposite from the pulling force. Basically you kind of like, it's basically a negative force. Think of the friction force as a negative force compared to the pull force. That's kind of how it is. And also let's say you have a box and there's a rope attached to it. That is a force, but that force is kind of like tension. It's like that's what it is. It's called tension because of like the rope. It like supposed to stretch it out, so it's in tension because of the mass of the box. Unit for force is newtons, as the smallest, just an n. So an example question: a crate is pushed with a force of 10 newtons at an angle 45 degrees below the horizontal. What are the horizontal and vertical components of the force? Well, first of all, to understand everything, let's just quickly understand what does it mean by below the horizontal. So to understand that, let's draw like a graph. This is the y, this is the x, as we know, and below the horizontal means it is below here. So as we know, if it's like going this way, the angle is positive. However, because like it's below the horizontal, that means that the 45 is a negative 45. And if you are confused, like, oh, well, how do I know if it's like in the question, it's going to say like, over here, like, what's the wording, all that type of stuff. And in general, if it says minus 45, why does it say positive 45 here? I will explain it literally right now, guys. So look, to understand it, first of all, let's explain what are the components. So it's talking about the horizontal and vertical components. Horizontal is like the, as we know, horizontal is when like it's like this. Vertical is like when it's one of these two. So left and right, up and down, right? So here's our force that we know about, the 10 newtons one. As we can see, it's going like this. And we have a vertical and we have a horizontal. So let's just draw kind of like this type of line here. So we have a horizontal component here and a vertical one. And this is where we kind of understand where's the negative from. So look, horizontal is like this way, right? Just like here, the angle that's like put like below the horizontal, it's in the positive x. So our horizontal is positive. Over here it's positive. And our vertical, as you can see, the y is negative. So that's where we kind of got the negatives, all that type of stuff from. Is going down, as you can see, so like another of it being negative. Now, to find what, so this is the 10 newtons one. To find what this is worth, let's call this fx and this fy. So to find x of the force, we have to do this calculation. So we have to use the force that we have, 10. And for the x, we use cos and minus 45, which equals to 7.07 newtons. So when you, for the x's, it's always a cos. For the y, it's sine. So negative 45. And here you can see that it's a negative 7.7. So also, again, we kind of see this thing where like the y is a negative. You might think, wait, these two, like, they're supposed to add up to give us 10. These two, they don't even add up to, like, a 1. They add up to 0 because, like, they're exactly the same, and that's a negative. So it takes away from the equal 1. However, these are not numbers. These are vectors. So a very kind of easy way to explain it is, first of all, let's even talk about when you add and all that. So let's say I have a box and a 5 newtons force is pushing it, and then another one is pushing it. Because they're working together, we are able to add them as numbers. So that is a 10. All this together is kind of forming only 1. You can kind of think about it as like, let's say you're like described to like shorten this type of thing, like instead of 2 you should have 1 line. So you just add them because like they're doing the same thing, so you're able to add them. Now another example is, let's say you have 5 newtons pushing to the right and then are 5 newtons pushing to the left. Because they're now fighting, like this is a whole entire scrap going on here. They're like, no, it's going there. No, it's going there. So you can think of this one being as negative, or this one being as positive, and this one being negative. Most of the time, the one on the left is negative because of the friction, but like these, they'll cancel each other out and become a 0. But in this situation, it's not like that. You might ask, but why? Like, it doesn't make sense. It is vectors, they are components, it's not numbers. Guys, it's a line, it's not a number. So the kind of way of thinking about it is, let's say I have a box, right? And then I get a force that works on the right to it, and then another to the down. It will kind of go somewhere like here, because, you know, this one is pushing it here, and this one is pushing it down. So it will go down to like an angle. And you see this one that I just did, like this is the same thing that we just had in our question. So initially in the question, it says, like, I forgot to like draw. So we have a box, and the force is 10 newtons, and it's acting on a 45-degree angle. So this is what we are seeing. This is what the question is implying to us. So see how this one does exactly the same. Like, it would also, like, after a while, this box would probably be around like here. And same with here, they go the same direction because it's like work done. Like, imagine these two, they're just workers on a factory. They have to make it get here. It's just basically kind of like work being done. Like, you just kind of have to have the mindset to understand. So these two, they don't add their like forces, they kind of add what they're doing. So these two, they're not equal to this as in power, they're equal to this as like the force, like what's it doing. So another way to explain it, let's say you have like, you're in a park, right? And you're going through a pathway, this is a pathway. You're supposed to go like this. So this is the start, this is the finish. So let's say like you have a friend, like your friend is green, you're blue. Your friend is like, you know, like the good boy, he goes like this. But you're like the gangster or whatever, you're going like this. And you would come first. The reason for that is like this, it's the same kind of direction, it gets you at the same point, but it's not equal by the distance to this. This is much shorter. It's literally logical. That's why, you know, the paths that we have in like the cities, like, you know, human power, we literally like create where like the paths. So the answer in general would be these two. These are the components. Now here is a great example to like to understand what happened in the last question. So now we have a box, right? And it has two components. So this one is moving it to the left, this one is moving it to the right, and this one is moving it upwards. So by the time it would get, so it would be here, so like it goes like this again. And what we're gonna do here is we're going to find, like, what if there was only one? Like, instead of these two like doing, what if there was the one that did the same thing as these two do? So to do this, let's just quickly like imply the fact, like, usually there would be like, you know, some friction here because like moving, right? Let's just think of a place where there's no resistance. Literally, like, let's say we're in like space, right? We're in space, there's nothing stopping this box. It's unstoppable. It's going to move this way without nothing, any air, nothing stopping it. So just forget about that kind of stuff right now. First of all, we have to go to the basics of maths and to what we did last question. So last question, if you remember, we formed kind of a 90-degree triangle. So over here we have the vertical component and a horizontal component. As you can see, we have a 90-degree angle now, and because of that, we're now able to find out what is going to be the resultant vector, which is kind of like FV basically, in short words. So the resultant, because like that's the same thing as the result of these two. These two have the same result as one of these. And the way you find it is the basics of maths. So you know how c squared equals a squared plus b squared, right? It's kind of same here. So let's say the fv equals square root. Like, we're going to square root straight away because like we can do it like as like here, but what's the point? We can just like input this in a calculator straight away. So we have the 4 squared plus 3 squared, and that equals a 5. So the frictional force is a 5 newtons already. We already know that. But also, if you can see, it's on an angle. And to find the angle, the theta, we have to use our was it SOHCAHTOA, right? And to find theta, as we know, we have the opposite, we have the adjacent. We also have the hypotenuse. However, we kind of we need to use only these two. So it's the tan inverted 3/4 equals 36.9 degrees. So the end result of this thingamajiggy would look like this. Box our new line force 5 newtons, and the angle being 36.9. Done. And this is literally the same as this, guys. You just have to remember that. Now here, as you can see, we have another example question, and this time the forces that you see here, they're the ones that we already went through. This is the first question, and this is the one that we literally just created. And what we're gonna do now is we're going to kind of like, again, create another force, like a singular force that would be, we'll kind of create the net force. We're going to be creating the net force of this whole entire thing. So first of all, we have to do to create the net force, like the final of these two, like, you know, the final boss, like the biggest line, like these two are already like bosses. We're gonna create like the like, you know, boss man. So let's just make a bigger box, and we have to kind of expand these two, like, you know, with the two component forces, which we already know, we already did. So x is 7.07 and the y is 7.07 minus, so these two are newtons. We already had them, I forgot. 3. So over here, yes, the line is not here, they're not matching, but it doesn't matter because either way the result is the same. Like, it doesn't matter where like the angle is. It does matter, of course, because like if it goes here, then it will go this way. However, because we're dealing with two like forces this time, it doesn't quite as matter because at some point they will cancel each other out. Also, if we see over here, it was pushing it like kind of this way, like kind of upwards to the right, and this one will also push it upwards to the right. So it's all good, don't worry, guys. Now we have to find the final forces of x and final forces of y. How we do that, guys, is, wow, we're able to actually add them as numbers. So finally something, you know, a bit more easy, a bit more like, you know, closer to us. So the net force of x, you can call it, this is basically the net force, like net force, because it's all together, right? So you can call it net force x, but in like while we're studying, it doesn't matter, just write like that in an exam or whatever. So the x over here is 7.07, the x over here is 4, so plus 4, 11.07 is going to be negative 7.07 plus 3, which will give us negative 407. Now we're able to make a triangle. So horizontal and the vertical. The vertical is minus 44, 7, 11.07, and again it's a negative, so it's going down. Just remember that, just as a quick note, you know. And then like this line, we just add these two as you remember, like the square root of them. So FRFV, I'm sorry, 11. So this equals to 11.8 newtons. And over here we have the right angle, so the thingy will be here. Why not here, you might ask? Because, and the reason it's here is because if you think about it, like let's say the box, right, we're having the force, it's going to be over here. Like if you kind of change the direction of it, of going like this way to show us, that's kind of where the angle would be. So the degrees is negative 20. X, I mean, it is positive, so it's going to be here. And the Y is negative, so it's going to be here. So it's going like that. So this kind of, you know, and then it was positive, but it turned out to be a negative. It's kind of the same thing here. If you want, you can put the negative in exam. I'm not really sure if that counts. However, yeah, that's everything about the forces. Goodbye.